The purpose of this video today is to show you the difference between regular laser grade, flat grade design versus variable grade design and what that can do to help you minimize cost in your dirt work. Now here what I have is a 71 acre field. Section 1 here is one field and it is 65 acres. This section 4 I have excluded it, so it will not be in the design. This pad line right here is on top of a backbone, and we will be watering from it to the low, which is approximately on 235-degree angle. Now this section 1, I've sectioned it out, and best fit comes up with 4 3/4 tenths of grade. So real close to 5/10 of grade, which is a lot of grade. I did this because I wanted to create a model here that we could think it was apples for apples. So with this design, our contours would look like this. So this is every 2/10. So if you're a rice grower, this may not be a very good solution for you. But if you're just trying to run water from the top of the ridge down to the bottom of the ridge, this variable grade design will save you quite a bit of money. Now on this flat grade, we have 533 yards per acre. This is a whole 65 acres, totaling out there of 34,761 yards. So that is one field best fit. Now I have designed another side of this, or another option of this, of what we could have done here. It was sectioned out this bottom section 2, which there's a hump there, so we'd section it. We'd still use the same low. Section 1 would be a fairly big field. This section 3 I just put through there so we wouldn't have to, this section 3 would balance in itself without worrying with this other big section here on section 1. Again, section 4 is not included. With this design, we still have 401 yards of dirt to move on the 65 acres, totaling out to 26,185. This design would look like this. See how our grade comes on this little small piece. Our grade comes from this bottom down to this drain that is currently in this field, and then the rest of it would all drain toward the southwest. Now, in my opinion, this is not a very good design, so we would still have to work with this to get it to where we would like it. Now, flipping over into the irrigation side of this, to get the irrigation water from this top ridge down to this bottom, the whole field, my perimeters of this field are minimum slope of 1/10.5. So that means we will have a row slope of 1/10.5, no less than that. That row slope would be on a 235-degree angle throughout this whole field. Now our max slope is at 1%. That's a lot of grade, but since we were just trying to get water from the top to the bottom, we figured we could work with that. Now for cross slope, I have in a max of 1/10.5. That max of 1/10.5 is pushed to its limit in this area of this field. Typically you would not have a minimum slope of 1/10.5 with a cross slope of 1/10.5. You would want to half that, but since this is only a real small area, we was thinking that we was able to get by with doing the 1/10.5 and 1/10.5. We did not want to make this all conform to a shallower cross slope than this 1/10.5 right in here. With this design, we are still on 65 acres, and we're coming up with a total moved of 268 yards per acre. That would total out at 17,648. So just by varying our grade throughout the field, cross slope and row slope, we're able to significantly drop our yards per acre and total moved down to something a lot more affordable that is approximately 35%, 40% better than what the straight grade design was at 533 degrees. This field was work like this. Our cut fill map looked like this here. This field was work like this. Our farmer really liked the way it turned out, and it seemed like that this here would work for us. So that is in short the difference between variable grade design versus regular straight flat laser design.